the concern of environment protection, followed by the policy to promote renewable energy, conducted to the introduction of renewable energies in the electrical power grids. It's known that renewable energies as solar and wind has a fluctuation character, and that character impacts negatively the stability of electrical power system. It's also known that energy storage is a solution to improve the reliability of renewable energies integrated in the electrical power system. Compressed air energy storage has been recognized to have a long lifetime, and also it is a green energy because it doesn't produce a greenhouse gas. It's also recognized that compressed air energy storage has a efficiency because it's of the low discharge rates. It's why we decided to see how the compressed air energy storage will behave to voltage and frequency regulation. This station is called compressed air energy storage process control with SCADA. The main objective here is to use compressed air energy storage to supply renewable energies as solar and wind to stabilize the electrical power grid by regulating the frequency and the voltage. The first step of that project is to store the air. To store the air in a tank using a motor, and that motor will run by a drive. It means that we can regulate the speed of the motor, the power of the motor, to be able to stabilize the frequency and the voltage when we have high frequency or high voltage. The second step is to generate energy using compressed air when the frequency is low. When we have those frequencies, it means that when there is not enough solar or voltage, we will use the air that has been stored in the tank to produce energy using a pneumatic motor which represents an air turbine, a gas turbine, a generator which will produce EC current. Then this EC current will be used using the sensors. Then those sensors will measure the frequency and the voltage and convert it in analog signal for the PLCs. Then the PLC has a PID controller. That PID controller will output an analog signal which is integer from 0 to 27,648 to a IP converter. And that IP converter is to convert the current, this current from 4 to 20 or 0 to 27,648 to a pressure. Then we will get a output desired pressure to the motor, to the turbine. Then this pressure is controlled. Then it will output a desired pressure to control the frequency and the voltage. We have sensors. We have frequency meter. Then we'll convert the frequency and will output an analog signal 4 to 20 milliamps. We have controllers. The Simatic 1200 is the main controller we have used here. It's added with an analog module, input, output. Then we have analog input and analog output. We have a remote system. That remote system, it should be nearby the load. Then the signal will be transferred to the remote system AT 1200 SP to control our load, which we call distribution lines. We have a drive that is schematic G120. Then this drive use a Ethernet cable for telegram communication. Then we have choose the telegram 1, which is a PZ2. Then we have 2 words input and 2 word outputs. Then here the motor is represented by the motor pump is represented by the motor. Then this motor will regulate its speed, its power according to the error which has been detected by the TID. Before to program the PLC, we have to set the sensors. Then to set the sensors, we have a frequency meter. This frequency meter will measure the frequency and the output analog signal. This analog signal, we have analog signal output, then 4 to 20 milliamps. Then to set this, we have a setting parameters here. Then you have to press in the set to set the parameters needed to control the PID. First of all, we have alarm. You have to set the alarm. We have alarm low value and we have alarm high value. To set the alarm high value, we have to lift here from here, reset, then we lift till we get the value that we want. Here I have 45 Hz. Then to set, I have to press in set. If I press 1 in set, it's already set. Then I can move to the next. Then here I have alarm, that is the H. H is a high value of alarm. I can continue. I have alarm 2. Alarm 2 is the low value of the frequency meter. Then I have to set it to 43. Then I have to lift. Then I have 40. Then 43. Then I have 43. Then I can set again. I have the decimal. The decimal is to how you want to read your values. I don't know. I don't have to change it. Then I will continue. Then here I have to set my analog signals. Then to set my analog signal, we have to follow the data sheet from the manufacturer. Then you cannot set it without the data sheet. Then here I will set a function. It's for the low value of analog, there is a function. Then you have to set your 4 milliamps according to the manufacturer, the function of the manufacturer. Then the high value of the analog, is also a function. Then you set that function according to the 20 milliamps you should get in output. The next step is to set your transducer. Then you have 0 and a span. Then setting this transmitter means that you are setting your range of analog output signal. The input is voltage. Then it will convert the input voltage to output current from 4 to 20 milliamps. And this signal is taken to the analog module, input-output module of your PLC. And from here, the output we have to go to the IP converter. Then to set the IP converter, there is 2 ways. First, we can use a ammeter. The ammeter, you measure the current, output current from the PLC. you connect to the IP converter, and you can set easily your output using this span and 0 to set the range from 3 psi to the value of the pressure you want, maximum value of pressure you desire. Then the second is to use move instruction in PLC. Then using move instruction, you input you output the PLC analog signal, which is integer, and 0 to 27,648. Then you can set your IP pre-compressor output pressure according to the desired pressure corresponding to your analog signal. So after doing that, we can go for the PLC programming and the SCADA software programming.